In number 3, the length of a rectangle is increasing at 3 inches per second. If the area is increasing at 42 inches squared per second, how fast is the width changing when the length is 6 inches and the width is 4 inches? So we'll start off with our diagram, and we're going to have a rectangle, and we have a length and a width. That's about all we know for our drawing. For our rates, we know that the length is changing with respect to time at a rate of 3 inches per second, and the area, dA over dt, is increasing at a rate of 42 square inches per second. What we're trying to find this time is how fast is the width changing when our length is 6 and our width is 4. All right, so what that means is we're going to need an equation in terms of L, A, and W. So an equation that has length, width, and area is actually the area formula for a rectangle. So area equals length times width, and that's really all we can do there. So now we're going to go ahead and derive. And so we'll take the derivative of A with respect to t, and we're going to take the derivative then with respect to t of length times width. And you can see we're going to use the product rule there. So dA over dt will equal 1d2, so L times dw over dt, plus 2d1, so w times dl over dt. Now notice in this case, we're looking for dw over dt. So we can go ahead and substitute everything in and then solve for this at the end. So let's go ahead and substitute. So dA over dt is 42, and the length will be 6. We don't know dw over dt. That's what we're looking for. And our width is going to be 4, and dl over dt is 3. Now let's go ahead and solve. So we'll have 42 minus 12 over 6. And so dw over dt is going to be 5 inches per second. So the width is going to be increasing at 5 inches per second when the length is 6 and the width is 4.